here's another application problem that involves bearings, and it's a boat traveling with a bearing of 35 degrees, propelled with a force of 750 pounds, and then a wind with a bearing of 320 degrees exerts, and this is a wind that's coming from this bearing, okay, so it's coming from that, and so you got to remember what we did in the last problem when it says coming from, and it exerts a force of 150 pounds, and so I want to know the magnitude of the resultant force and what the boat's new direction is in terms of bearings. So I thought this would be a good one for you to go ahead and try yourself, so you can hit pause, give it a try, and then start the video back up again, and then we'll do it together. Okay, so let's go ahead and give this a try. I want to try to make my diagram a little bigger here. So I don't know if this is going to give me enough room here. So north is like this. And this says the boat is traveling with a bearing of 35 degrees. So something like this, where this is 35 degrees. And the magnitude of that is 750 pounds. So this is a force moving the boat. And then the wind is exerting a force of 150 pounds. And the wind is coming from a bearing of 320 degrees. So 320 degrees would kind of come around here. Here's 270, so it'd be 50 more degrees. So something like this would be your this would be your 320 degrees. And so, but the boat, the poundage that it's exerting is actually coming this way, okay, because the wind is coming from that direction. And this is going to be 150 degrees. So remember, we need to find this angle, so this one is easy enough to find. That would be 65 degrees. And then this one here is actually going to be the opposite of this. So this angle here and this angle here are equal. Those are vertical angles. So this, remember, was 270 to 320. That was 50 degrees. So this is actually 50 degrees here. So the actual angle from here to here looks like it's 115 degrees. Okay, so that's 115 degrees, not 90 degrees this time, right? So now I'm going to take this and bring it over here to make a parallelogram, and then from here to here to make the other side. So that's this angle from there to there, and so my resultant force is going to go from here to here. That's my resultant force. So this is 150, this is 750, and so this 150, that should not have a degree there. That's 150 pounds. This is 750 pounds. And so we got to use the law of cosines here. So I'm going to make that C, and then I need this angle. And to get that angle, I'm going to do 360 minus 2 times 115. 360 minus 2 times 115 equals 130, and then I'm going to divide it by 2, and that would be 65. So 130 degrees, and then 130 divided by 2 is 65 degrees. So this angle is 65 degrees. So now I can use the law of cosines. I have 150, 750, and an inner angle of 65 degrees. So my c squared is 150 squared plus 750 squared minus 2 times 150 times 750 times cosine of 115 degrees. And then my c is going to be approximately. So let me put all that in and then take the square root. So 150 squared plus 750 squared minus 2 times 150 times 750 times cosine of 65 degrees. And you know what? I wrote this wrong. This should be 65 degrees. Okay, and then I get all of that, and then I'm going to take the square root, and it looks like I get 699.93 whatever, so approximately 700 pounds. Okay, so this is approximately 700 pounds. And then what I want to do is I want to know the bearing. So I need this angle again. Okay, so this is 150, and I know that this is 65. I know that that is approximately 700, and so I'm going to call that theta. So then I got my sine of theta is to 150 as the sine of 65 is to 700, and my sine of theta is approximately, we'll do sine of 65 divided by 700 times 150, and I get this thing, 0.1942. So my theta here is approximately, I'm going to do the inverse sine of that. We'll say inverse sine of the answer, see if it gives it to me. I think it did, 11.2 degrees. 11.2 degrees. Now that's this angle here, so I got to add it to the 35. So the bearings is 35 plus 11.2 would be 46.2 degrees. So I'm thinking it has a magnitude of 700 pounds with a bearing of 46.2 degrees. So in the next several videos we're going to talk about resolving vectors. Okay, we found the resultant of vectors. Now here, given a vector, can we find the components, the two components that make up that vector?